Testing. Testing. Okay, so the stream just died there. Too many things were going on, so back at it. To set the context here, we were using Blender static data set that we are going to use to train a neural radiance field from scratch, and using ChatGPT to write a bunch of this code for us. So yeah, we were here basically sampling a bunch of points around a sphere, around an object, and then saving that. So maybe, can you write Python code for me that saves camera image file of PNG image file with size 28 by 28. This is my code, so all right. Okay, so it's previews utility. It sets the render resolution, and it renders image, render result, file path, camera. So why don't we actually go ahead and try to copy that and put that here. So before that, we're going to have to write the camera image size. We'll say 28 by 28, and then we'll replace here with this tuple that we just created. Then render the image and save it to a file. We need the image file path. And we'll say dash emp, or actually give it the exact file path of this repo here. So we can hit Control B and then come here, say copy path, put that in here. And that is the full path. And we don't this part. Say here the file path that we want to save this to is actually indent that so it's read. We'll say file path plus, or why don't we actually bring formatting here as well. File path, and then call it, we want to know which of the samples it was, right? So I think we need to put double quotes around this. This is a little weird. Why don't we actually just say I don't know if Windows is going to be able to, or Blender is going to be able to consume this file path because it's a file path. File path and then I. Okay. We copy that and we open Blender again. Blender to the side here. Let's tab script. Not like let's see if this actually even hit this little play button here. Script. Okay. So it ran it. So now let's go into our file explorer and we can actually see all the way to the disk, see the EMP file. There we go. There are our 50 images. I mean, obviously these are all kind of trash, so let's get back to our. So one of the problems is you can have our little monkey head, but we have this big. Let's that big. And then the other problem we have is the camera is very, very close. So let's make the sphere a little bit larger. 5. Make this a little bit smaller. Let's only do 10 samples. Make sure that everything is fine beforehand. And now let's go ahead and file path. Copy that. The monkey head as well. There. Spawns the monkey head and a thing. Here we go. We have our little 28 by 28 pictures, but every single one of these from the same exact view. Okay. So it seems like here the camera location is not being updated. I'm just making a string here. Right. So where were we? Yeah, we had our camera, but the problem is the camera location is not updating. So why don't we put a little print statement? Okay. Camera location is XYZ. Yep, that's fine. Head copy that. We'll be back. So the problem is it's not going to blend. So if we can figure out what's going on here. There's a theta and a phi. And that's effectively the view angles, right? And the view angles are actually what we're going to feed into the neural net, right? So what we should do is we should save, that's what we should put in the file name. So the file for the file name for this should just be the theta and the phi. All right, and let's actually ask ChatGPT. Can you modify this f such that theta and phi are always shown with 4 decimal places worth of precision? I think it's like 0.4 F. All right, so if we copy that here, run it. It's another monkey head here in the object outliner. So this little area here of the Blender screen, how many different objects there are. There's actually 2 monkeys at but open up our file browser, open up our temp. Here we go. So we can see the theta and the phi are correctly rendered in the name of the image, but we're still getting just always the same top-down view. So Blender Python update to move object. I think the problem is that we're setting the camera position, but we're not like updating. Refresh scene after move. Blender. So maybe it's not that the scene is not updating, but the actual camera is just very slightly moving, right? And okay, these are radians, so that's correct. You know what we could do is we can go here and we can add little sphere. So let's do primitive sphere add, and we'll add little tiny spheres. 0.01 at XYZ. And what this will do is it'll add a tiny little sphere at each of the positions of the camera that we're sampling. So then we should be able to see it in our scene. Yeah, so any of these primitive sphere add in a Blender function. You know, primitive monkey add is one. Okay. Primitive icosphere add. Blender. Heat. There. Python script console. The way to if ChatGPT knows. How do I show the system Blender? Top menu, go to Window and select Toggle System Console. Nice. Keyword size unrecognized. This part here, the size of the sphere is unrecognized. Let's get rid of it. Back in there. Play. Taking a little bit longer now, so actually gonna a row. Crashed our computer again. And this is why you don't use Blender, guys. Open up our terminal here. Let's kill Blender and task. Really don't like Windows for this reason. I think it really died there. Primitive icosphere add. So this has a radius. So I think that might have been it. Radius equals 0.1. one. So now let's do that. Let's reopen Blender. Tab, delete. Script, play. And I guess it ran. Here we go. Here are all of our. Okay, so actually let's make this big so our sphere. Make them make these a little bit bigger. 0.10 times big. Back to the layout. So these little spheres here are the camera position sampled. So it's not quite a sphere. You know, it's not like a mesh grid. It's basically sampling around this monkey. But one thing to note is that the camera is always looking down, right? We actually want the camera look at the monkey. And that's going to be the hard part, right? Because I think we weren't really able to first thing first, right? Let's modify this. Modify this code such that it is more of a mesh grid. All points. Mesh grid is a NumPy function, right? This is very bad instructions that I'm giving to ChatGPT. I'm making a reference to a different Python package that it doesn't even. All right, here you go. Look at that. It got what I was saying. It understood. It understood that what I wanted was the NumPy mesh grid. And it's like, okay, here you go. Here's the mesh grid. Okay, let's replace our little thing with this. Let's port NumPy. So this is a mesh grid between 0 to math.pi of the camera's poles. This is going to sweep over all possible, or the thetas go from 0 to 2 pi, right? Because you basically want it to go all the way around the object. But then the phis, which is the kind of up and down angle, you only want it to go to pi, right? And for theta, I don't think you need this weird double for loop here. I think you can say for theta phi. Probably fine. All right. Go back to Blender. Let's this. And let's a number of guide there real quick. Open it. Cube. That. Okay. Thinking. Here we go. All right. So this is all the camera position now. So that is much more of what we want, right? We're sampling all the way around in theta. We're sampling 4 different points phi. That is very good. I like that. Okay, so now what we need to do is we want the camera to look at the object. So can you add a tracking constraint camera object such that it tracks monkey head? First things first, get the monkey head object. This is going to be, I think it's actually called Suzanne, not monkey. Tracking constraint, new head, track negative P up Y. Okay, perfect. We'll try this out. Open up Blender, object, back to scripting. Called Suzanne. Copy that. Let's not add the little sphere. New. Let's put in our script. Play. Let's see what happens. Okay, so let's now open up our file explorer to our temp file and a lot of pollution. Go ahead and delete crap. Empty out the TMP folder. Let's make the camera a little bit closer. Make the object a little bit bigger. And let's retry this. So one thing we can do is we can actually come to Blender here, go to the layout, and because we have a tracking constraint now, be able to move the camera. You can see that it tracks actually up a new one here. This, so the camera is seen. And then you see if we select the camera and we move it, it always looks at the monkey. Okay, let's go back to scripting. Copy this. Actually, rid of this Blender scene. So part of the reason I keep reopening and closing Blender is that Blender is keeping track of everything that you're doing, because in Blender you can like undo and redo, so it has like a memory of every operation you've ever done that you can undo and redo. So if you keep running scripts over and over and over again, like you're kind of adding more and more and more to the memory that Blender is taking, and that's eventually what was causing the crashes. So especially for something like this where we're just doing something at the very scratch, maybe actually delete the default that. So this cube here, I keep deleting it at the beginning, but it's always selected. When you open up a new Blender scene, it's selected by default. So bpy ops.object_delete will delete the object that's selected, which is always going to be the cube. So that's a little hack there. Script there. Let's open up our T, make sure it's empty. Run. Okay, finished. And here we go. We have monkey head from the top. We have monkey top. We have monkey head from angle. We have monkey head from below. We have monkey head from the side. Looking pretty good. So I think part of the issue here is that the image size is a little bit too small, right? 28 by 28 is disgustingly tiny. So let's do a little bit bigger. I want to say 128 by 128, but that's, I'm afraid of going that big. Let's do 56. 56 by 56. And why don't we also write code for me that makes this monkey head object purple. We're going to add a purple texture to this monkey head. All right, perfect. Open up Blender again. That in there. Play. Python. All right. Now we have a little bit better picture, or a little bit larger. And they're from every single. Very difficult to see. But I think the basic script is there. All right. Cool, guys. We have a synthetic data generation script. M9, I don't know if you're watching, the stream has been broken up into like multiple chunks here, but yeah, I'm using Blender to create a synthetic data set. I do not think ChatGPT is actively learning from user input. I think they are probably they're definitely collecting the user interactions, and then they'll probably train with it at every X amount of time, maybe every couple months. They'll retrain with the user interactions. It's definitely not like a super fast loop, right? Because the training takes so much time and it takes so much money to retrain that they're probably not retraining it constantly. But I wouldn't be surprised if they've retrained it a couple times since they released it. Okay, so close out Blender here. Let's commit what we just did here. So all this synthetic data set. Commit. Oh. Cat is. I will have to back. An absolute disaster today. Sorry again for the break there. So set the context. So we're building a NeRF from scratch with ChatGPT. We just used Blender and Python to create a synthetic data set of images and camera positions of a monkey head and okay, maybe the next thing we need to do here is do a kind of loading. Right, so if we remember, we made this model yesterday, or ChatGPT made this model. And basically the input is 5-dimensional, and it's going to be the position of a point, and then the view angle, and then the output is going to be the color for that. So we need to create a kind of data loader script. Actually get chat create a data loader function that loads images PyTorch dataset loading function that loads images from a directory. The name of the images contains the learning target. So they regex out. Let's start with that, see if I can get that. Oh no. Great. Failing here. Going to be a loss function. We have to wait a minute here for this data set function generate on okay. Organized in the following way. But You know what? Why don't we actually put this in a new file called, say, dataset classes. Put this in. And then when we actually train, we're going to have to load the data sets here. And we're going to have to import from data image data set. Static data set. Okay. We don't need to put this pattern because that's going to be the same every time. Right, and there's going to be a train data set, and then there's going to be a test set. And then we're going to have a train data set. Actually, let's call this trend test. And we'll have a val data set. We don't actually need this test function. Train, valid, and test. Train dataset path is going to be here. Port utils data loader of set. Our batch size is going to come from. This is going to be the train data loader. Okay, so we're going to have the load the test data set on Copilot autocomplete. There's no shuffling for the test. And there's also no shuffling for the validation. All right, perfect. Create model. Okay, so now let's go back to our data file here. And again, we called this synthetic data set. So let's name this class to synthetic data set. This, I kind of prefer that as instead of the like from imports. DIL import image. This is regex, the OS. Okay. So you have the root directory. Oh, you don't need this crap. Like sometimes this is basically like the reason ChatGPT gave us this is because a lot of times people in a classification problem, such as cats or dogs, they'll have this kind of format, but we're not going to have that. We're just going to This is making a list, all the files. I think what we can do here is we can actually tell it this. Can you modify the regex class above, extract data and phi from the file names with regex? This is what the file names look like. This is the pattern. Okay. That seems correct. This is the part here. Match. I think that's actually quite good. That's what we want there. All right, so this dataset object here will go into our files. Let's see, temp. So for each picture of the monkey, such as this one here, right, there's going to be a theta, and then there's going to be a phi. And this will basically extract the theta and phi from the file name the way we intended it to be. And it'll load that for you. And we're going to have 3 different data sets. We're going to have a test, of course, a train, and a load. Or a test, a train, and a validation. Then those 3 different data sets will be used in our training loop here. Create model. So actually from model import model. Called in NeRF. Why don't we actually also take these here? Num layers and num hidden. And we'll expose these as hyperparameters here. So when we're putting them here, we're basically just exposing them as hyperparameters so that whenever we eventually optimize this, we'll be able to pick different values for these. So get rid of this learning rate scheduler. NumPy. Batch size. This is from our previous project, so we don't have an encoder. But we do have now layers and num hidden, which is going to be hp.voice called num layer hidden. And for these, have maybe a couple different values for them. Maybe for number of layers, we have 1, 2, 3. And then for the number of hidden, all like 28, then 250. 120. Okay, so we're slowly accumulating, I think, 8. And we want our from train import train. And our train function here, this should return a float, right? Return a score. So yeah, return the best loss, right? So when we actually optimize, we're going to get the best loss from our train function. Copy paste stuff here. For these 3 here, or these right here, can delete that, and all of these are going to come from the hyperparameters. So and train dataset valid test, they're all going to be hard coded. That as it. The run name also needs to get passed in. We can base the run name on the number of hidden and the number of layers. So let's do hidden. Also a And again, the run name here is going to be used for when we actually log our stuff. So for purposes. All right. So we've done a little bit of work on the optimization. Done a little bit of work on the training. Got some more time. We've loaded these data sets. We've created the model. Now we want a loss function and a optimizer. Can you give me a PyTorch code that creates an optimizer and loss for, let's just say optimizer, that is used to train a NeRF? Okay, it's using, okay. Atom optimizer. Okay. We're calling it LR. I don't think we need weight decay, but epoch in range num epochs or puts loader. So we have our train loader. And it's going to be image. Right, the way our data loader works, it gives us an image and then it gives us the theta and then phi. So that's basically what we're going to get in our training loop. So it's going to be image theta phi. First thing you're going to do is zero the gradients. Then the forward pass. This is going to be more complicated because we actually have to actually do neural rendering. You're going to have the loss, have the backwards pass, okay. And the evaluation, so validation. We're going to be using validation data loader here. I'll do the let's test. So testing will happen after the training and validation, and it's going to be a similar kind of situation. Okay, and our best loss is keep track of best loss so far. Loss. Check to see if loss is the best so far. Okay. For best loss. All right, I think this is good. We have our whole rendering stuff that we were doing yesterday. Why don't we actually save what we currently have now, commit it. GitHub. Let's dataset loading, training boilerplate. All right, so I feel like we're kind of at the limit here. I think if we want, the next step here is going to be to actually like kind of run these things and debug it and actually step through this code and make sure that it actually runs. But if you weren't here at the beginning, I actually just changed my setup here, and I'm actually on my Windows computer, which is no good. My Windows computer does not have all these dependencies installed, and getting the right CUDA version on this GPU is going to be a pain. So I'm going to wait to do this until we have the Linux computer up and running, and then we can go ahead and debug through this. So probably end up doing that next week. It'll probably be the stream on Monday, but I think for now. Oh, and again, if you ever want to see this code, it's here in NeRF my GitHub. So feel free to go in there and check it out and let me know. If not, I hope you guys have a good weekend. Thank you for watching the streams, and yeah, let's have a fun year.